Hi, let's study about partial differentiation. So far, we'll be used to the term dy by dx. And if we ask what do you mean by dy by dx, we say that y is dependent on x. We call it as a normal derivative. Correct? I can say that when y is dependent only on x, then we have dy by dx. So again, a function y is dependent on x. But at the same time, if y is dependent on more than one variable, say on x and z, it can be x, z, m, l, p, q, whatever it is. If it is dependent on more than one, then we have partial differentiation. So here I have given an example that if it is dependent on x and z, then my notation changes del y by del x. It is dy by dx in the previous case. Here it is del y by del x and del y by del z. Okay. So let's see some basic examples in partial differentiation. Initially you may find little confusing. So of course I have some idea for that. So you just follow that, then after some 6 to 7 problems you will get the grip. Let's see the first example. V is equal to x square plus 2y square. Okay. First what you have to do is check v is equal to x term is there, y term is also there. So I can say v is dependent on x and y. If one more z is there, then I will write v is dependent on x, y and z. Here only two variables, so I will write del v by del x and del v by del y. Okay. Now how to differentiate partially? You have two terms. First of all, try to write it in pencil here like this. X square plus 2y square. First, I am going to partially differentiate with respect to x. So, other than x, whatever it is there, it's just a constant. This number 2 and y square, both are constant because we are partially differentiating with respect to x. So, this is just a constant. So, x square plus 5, if you differentiate, what you will write? X square differentiation 2x and 5 differentiation 0 you will write. So your task is just circle the terms other than x. As simple as that. So first x square is there, I didn't circle. So 2y square I have circled. It means I am not supposed to differentiate because this is just a constant. So x square differentiation is 2x and this constant differentiation is 0. So I can write 2x plus 0. Similarly, try to differentiate with respect to y. Rule is the same. I am partially differentiating with respect to y. It means x is a constant. Other than y, whatever is there, you have to circle it. Okay. So, x square is just a constant. I have circled it. Correct? Actually, I missed to circle 2 also because 2 is also a constant. If it's in multiplication, what we will do? We'll keep that constant as it is and differentiate the rest of our terms, right? Say 5x differentiation means 5 into x differentiation 1 we will write. So if it is an addition, x square I have circled it. So it's just a constant. If I differentiate a constant, I will get 0 plus this 2, let it be there as it is. Y square differentiation is 2y. That 2y into 2 will become 4y. Okay. Let's see one more example. U is equal to x square y. U is equal to x square by y. Here in this, I am going to check u is dependent on x and y. This is done. Okay, this is easy. So I can find del u by del x and del u by del y. So first let us find del u by del x. Again, the term is x square by y. But I can circle y. Other than x, I am going to circle. Okay. But this is in multiplication. This is not an addition. So I am rewriting this as 1 by y into x square. Now it's easy for me. This 1 by y is just a constant. You are going to differentiate only the terms that contain x. So 1 by y I have circled, x square differentiation 2x. You are just keeping the constant as it is. Remember, in normal differentiation, 5x, if you differentiate, you will keep 5 as it is and differentiate x, that is 1. Same way, in the place of 5, we have 1 by y. If I circle it, whatever there inside the circle is same as a number for me. So x square differentiation is 2x. 2x into 1 by y, 2x by y. Similarly, see here I am differentiating with respect to y. Okay. So which is a constant other than y, whatever it is there, it's a constant. Numerator x square is there. So I am just going to circle it. Since it's in multiplication, I am writing x square into 1 by y. Now I have to differentiate 1 by y. Okay. What is the formula for differentiation of 1 by y? Minus 1 by y square. Correct? In differentiation formula, y power minus 1 will come. Y power minus 1, correct? Let me rewrite this for you. Differentiation of y power minus 1. Okay. What is the formula? N x power n minus 1. Minus 1 y power minus 1 minus 1. So minus 1 y power minus 2 minus 1 by y square. That's what we are getting. Already we have x square into minus 1 by y square is minus x square by y. Okay. So every time whenever there is a constant, try to circle it. If it's in multiplication, just keep that as a constant. That number you will write it at last, and along with that you are going to write the differentiation term. If it's in addition, 5 plus x square. If I differentiate, what I will do? 5 I will write it as 0 and x square differentiation 2x. Same way, if it's in addition, we are going to write 0. If it's in multiplication, we are just going to keep that constant as it is, and then rest of the terms you are going to differentiate. Let's see one more problem. This I wrote it because already we have done one more problem, right? X square plus this problem, x square plus 2y square. Like that, similar to that, I am going to try this. Slightly I have changed the problem. X square plus 2xy square. I have multiplied one more x here. So if I differentiate with respect to x, it means other than x I am going to circle. So 2 I have circled, y square I have circled. Now I am going to differentiate only x terms. X square differentiation 2x. This 2 into y square both together is just a number for me. 2y square into differentiation of x is 1. So I have written here into 1. So this is your solution. Same problem I am differentiating with respect to y. Y means other than y I will circle. Rewrite the same problem again. Okay. So after rewriting it, x square is just a constant. I am circling it. Plus 2x is again a constant. Circling it. See here, for me 2 and x both are same because I am going to partial differentiate with respect to y. Since this is in plus x square differentiation, whatever which is there inside the circle is just a constant. It's just a number. Imagine x square is some number 3. 3 differentiation is 0. Imagine some 2x is just a number. 2x into y square differentiation is 2y. Now 2 2s are 4, 4xy we are getting. Similarly, you can try if v is, this is a simple example, 2x plus 3y. I am going to partially differentiate with respect to x. Correct? So it means y is just a constant for me. Hide that y value. 2x differentiation is 2. Easy. Similarly, partially differentiating with respect to y. So which is a constant? X is a constant. Hide that x value. 3y differentiation is 3. You're done. Okay. So if it's in addition, it will be faster. If it's in multiplication, treat that as a constant and write. So now it is not x and y. It can be in polar also. So u is equal to r power n cos n theta and v is equal to r power n sin n theta. Okay. So now we are going to partially differentiate with respect to r. Both u and v with respect to r and with respect to theta. Because u is a combination of r and theta. So I can find del u by del r and del u by del theta. Similarly, v is a combination of r and theta. So I can write del v by del r and del v by del theta. Okay. So first I am going to differentiate with respect to r. So which is a constant? Theta is just a constant. So it means you can hide it like this or you can circle it. Cos n theta, just forget about this. R power n differentiation is n r power n minus 1. It's in multiplication, it's just a number for me. So I have written cos nx as it is. Okay. Same way here, del v with respect to r. So which is a constant? Theta is just a constant. Hide this sin theta. R power n differentiation is n r power n minus 1. This is just a number. So I have written that constant as it is. Okay. So you can try this del u by del theta and del v by del theta also on your own. Rewrite the entire function, circle the constant and then differentiate the leftover terms. Here I am going to differentiate with respect to theta, which is a constant, r is just a constant. So in the main equation, I am just hiding r now. This is just a number for me. Cos n theta differentiation is minus n sin n theta. This r power n is just a number, I have written that. Finally, we can multiply. Similarly, del v by del theta. If I have written theta, then which is a constant? R is a constant. I am hiding r term. Sin n theta differentiation is n cos n theta into r power n. That's it. And see this problem, del u by del r. Okay. You are going to partially differentiate with respect to r. So which is a constant? Theta is a constant. Initially I have written in pencil and I have circled it. Now you try to keep that in mind. Theta is a constant. If I differentiate with respect to r, theta is just a number for me. So cos theta I am writing there as it is, and differentiation of r is 1. I am differentiating only r term. Differentiation of r is 1 plus k square into 1 by r differentiation is minus 1 by r square. Previous problem we have seen 1 by y, right? Same thing. And then just we have simplified it because it's in multiplication. It's not k square minus, it's k square into, because this is just a constant. So we have written this. Similarly, you can try del v by del r. Del v by del r means again theta is just a constant. So I am going to differentiate only r. V is here. So sin theta is just a constant. I have written this. It's in multiplication. R differentiation is 1. Then minus, already this term is having minus here. It's not visible. Minus k square into 1 by r differentiation is minus 1 by r square. Just now we have seen this minus and this minus, it's in multiplication, became plus. Okay. Now let's see what is del u by del theta. Now this time what I am going to do, differentiate with respect to theta, which is a constant, r is a constant. So this term is a constant, k is a constant, by r, everything is just a number for me. Okay. So the whole thing which is there inside the bracket is like some number, 7 or 8. So 7 into cos theta. If I differentiate, what I will do? 7 into cos theta differentiation is minus sin theta. Same thing I have written. Similarly, see here, v with respect to theta. Again, whatever there which is there inside the bracket is just a constant. Some number 8, because r minus k square is also constant by r. 8 into sin theta. If it's like that, what I will do? 8 into cos theta. I have written that constant as it is. And finally, sometimes if log terms are coming, you can simplify that. Log of root of something. Square root means power 1 by 2. Correct? So 1 by 2 log of m power n is n log m. So that will come down. 1 by 2 into log of x square plus y square. So now this is a notation. Del u by del x, I can write it as u suffix x. So it's too big for us to write, right? So we are going to use this short notation. So 1 by 2 into log of something is 1 by. So I have written that something as it is. 1 by x square plus y square into del by del x of that something I will write. Okay, again I repeat, log of something is 1 by that something into del by del x of that value. Because why I have written del by del x? We are going to find u with respect to x. If I write u y, then I will write here del by del y. Since it's del by del x, same partial differentiation, x square differentiation is 2x, y square differentiation is 0. Similarly, what is del u by del y? 1 by 2 is common. In log of that one, again this is also common, 1 by x square plus y square into del by del y of x square plus y square. So in the place of 2x, I will have 2y, that is del u by del y. So practice more problems and try to redo these problems on your own, so that it will be easy for you to solve problems that contains partial differentiation, especially in complex functions. Thank you.